Hello all. In this video we're going to take a look at how to go about creating your own simulations in Netlogo. I'm going to start by going over some general principles around programming in Logo compared to other programming languages, and then we'll go through the process of making a simple simulation. Won't really mean much as simulations go, but it's a good chance for me to show off some of the different features that you have both in the interface and in the coding side of Netlogo. But I'm going to start by talking through some of how Netlogo works, how to think about it as a programming language. Alright, so we're going to start with Logo syntax. Logo is an old programming language. It's been around for a long time. It was designed as a programming language for children, and it was built upon a programming language called Lisp or Scheme. These Scheme still persists in certain places, and it has a very different syntax. This family of languages have a very different syntax and a very different approach than languages that you might be more familiar with, like Java or Python or C. In particular, they don't tend to use a lot of commas or semicolons at the end of lines, nothing like that. And they tend to use spaces to separate items from each other. And when you think about things like functions, we often wrap the function call entirely in parentheses rather than putting parentheses after the first word. And very often there's a single keyword that starts a command, and then the options come after it. So looking here specifically about Logo, in the Logo that we're learning, you can have blocks of code, just like in any other programming language. Those blocks of code are typically marked with square brackets. Not curly brackets, which we use in other languages, but square brackets. And you can't just put them in anywhere. You have to put them in certain places where blocks are expected and not in other places where blocks are not allowed. We are not going to use commas as separators. That's not very common. We use spaces as separators. And function calls specifically do not use parentheses in the way that other programming languages do. So in many programming languages, you put the name of the function and then parentheses after it, and any inputs to the function go inside the parentheses. With Logo, parentheses here are optional. If a function call has 0 or 1 parentheses, you don't need, or 0 or 1 inputs, you don't need any parentheses at all. You just put the name of the function and you follow it by the value. If you need parentheses in order to disambiguate what's going on, you put the open paren before the name of the function, and then the matching close paren goes after the inputs to the function. So here I have an example. If you were calling this function foo and passing it 3 values, this is how it might look in Python or even in Java. In Logo, we would write that function call to look like this. And if instead we had a function call like foo of 3, we can write that, I believe. We can write that as foo space 3 with parentheses around it, or you can just write foo 3. Foo 3 with no parentheses at all. All right, so generally the name of a function or a control structure comes at the beginning. We don't have things where we have a name at the beginning and then additional keywords that occur later in the syntax. It's a pretty simple syntax, but the keyword goes at the front and then there are no afters. So one of the ways that that shows up is when you want to do a conditional statement. If you use an if in Logo, in this particular version of Logo anyway, the if is followed by a true case, and it cannot have a false case. If you want to have a true case and a false case, you use a different keyword. You use if else, which allows you to have a test and then a true case and then a false case. And you can nest if else's to make a chain conditional if you need to. All right, Netlogo comes with so many built-in functions for so many purposes. If you're wanting to figure out how to do something, then the chances are pretty good there's already a function that does it. You just have to figure out what it's called. The programming guide and the dictionary are good starting points for this. They will give you lists. You might have to do some searching to figure out the right terminology, but there's a lot of functions that are provided for you. All right, the rest of what I'm going to say has to do with the Netlogo world. I'm going to go through this quickly so we can actually see these in action. But the Netlogo world, we're building a simulation. It's a grid-based simulation. There is a world that has a certain number of rows and columns. You can change the dimensions. The default is that 0, 0 is in the middle, but you can also change that if you prefer. By default, the right and left edges and the top and bottom edges wrap around. So if an agent moves off the right side, they wrap around and come on the left, and similarly, if they go off the bottom, they reappear on the top. This is sometimes described as the world is the shape of a torus, but that's not super important as long as you remember it wraps. Every single cell in the grid contains a patch. A patch is an agent. It can't move, but it can otherwise interact with the other patches around it and with any turtle agents that might come its way. Turtles are active objects. They're agents that can move around. So they can move from patch to patch. Their position is given by a real valued number. So you can have a turtle that's at 1.5 by 3.21. That's perfectly fine. That makes for some complications, but it allows us to handle the turtle turning to any degree of heading and moving in any direction that you want. They do not follow the grid exactly. All right. When you think about agents or actors, there are 4 types of agents or actors in Netlogo. One, links, we're really not going to deal with very much. I haven't used them very much, and I haven't found a need for them. I've already mentioned patches and turtles. Those are 2 active kinds of agents. There is also an agent called the observer. Really, the observer is the thing that's running the simulation. You can think of it as like an agent perspective on the environment itself. The observer is what asks the turtles and the patches to do things. It is in control of the overall simulation. And it's really just conceptually an object, conceptually an agent in this world. All actors are objects. And by default, because of their type, they have a set of built-in attributes that they have, variables that belong to the object, and you can add more to any kind to either turtles or patches. You can also add more to the observer, but really, since the observer is the simulation, that's like adding more global variables to the system. All actors can perform actions, including performing function calls. You talk directly to the observer. The observer can talk to the turtles and the patches and ask them to do things. But once you can ask a turtle or a patch or a set of turtles or a set of patches to perform a function, and they will then run that function. So you do have to be careful when you write a function as to what kind of agent is going to run it. Is this something the observer is going to run? Is this intended to be something a turtle will run, or a patch, or what? I've already talked a little bit about these. I'm not going to say too much more about them. One thing I will say is that you can create specialized breeds of turtle. This can be a really useful way of conceiving of them. It's like making a subclass, and each subclass can have its own attributes and its own behaviors. So you can make breeds and you can do things with them, and it's kind of fun. We will look at that, but not with the example that we're going to do here. Now what I'm going to do is to switch over to taking a look at a blank view of Netlogo, and we're going to take a look at it and start creating a simulation in that realm. All right, now you can see Netlogo. I'm going to just make this a little smaller so you can see more of me. This is a blank Netlogo model. You can see that we're looking at the world. That's the big black box here. And we have space over on the left where we can add interface elements as we wish. I'm going to go straight to the code block and we'll start there, writing some code just to get us started. Most Netlogo simulations will have a setup button and a go button. Those are kind of standard. So I'm going to start by defining the setup function, which is what will run when we click the setup button. So what I want to do here, I want to make sure that if I click this more than once that it resets the simulation. So clear all is a built-in command that just erases all the turtles, erases everything we know about the patches, just does the basics. And then I'm going to have a setup maze function that I'm going to call. It doesn't take any inputs, so it's just the word. And I'll have another one, setup turtles as well. 2 is the keyword that says this is going to be a function definition. There's a different keyword if you want a function that returns a value. We aren't going to take a look at that here. When you're done with the function, you do have a special keyword end, which marks that you're at the end of the function. Now, I'm going to go down here a little bit. Part of what I want to do here is to have the patches form a maze, and I just don't want to type this all out. So I just copied it from a different version. I don't think I need quite this much space, so I'll bring it back up where you can see it. This is another function to set up maze. It's being called by the one up above. You don't have to understand entirely how this works. I will just note that I basically set things up in a certain way so that I could specify the walls of the maze, the outer walls and the inner walls. The map function here is applying this part. This is an anonymous function, so it's like a lambda. If you've ever worked with those, it's applying that to this list of values and putting them together. What is all this doing? It's building XY coordinates for the patches that are going to be the walls of the maze. And then for each wall list, we are going to ask a patch at a particular location to set itself to magenta. And those will form a maze. All right, I'm going to make the framework to set up turtles. We need to make the framework for that function. I'm not actually going to do anything in here. We'll just leave it blank for right now. I've written a little bit of code. I want to check it to make sure that it's working correctly. There are no syntax errors, so I hit the check button. It's fine with this. So let's go back to the interface. And what we'll do is to make a setup button. So there's a drop-down menu right here. We can select button. That is what was already selected. We click the add button so that it's highlighted, and then we click somewhere in the space, and that makes us a button. In this case, the command we want to run is called setup, and what I would like is that the display name is also setup, so I'll put it in both places and click OK. We're done. We've made a button. When you edit, I clicked the button, and this is what happens when you run it. If you want to edit a button, you can highlight it, then you can move it around. You can also right click, that's control click on a Mac. Right click on it and you can delete it, select it, or edit it. You can put multiple commands in Logo in this command box, but usually what we do is we call a function, and we have a function that's set up to do everything we want to do. So when I clicked on this button, what happened in the code was it went and found the setup, it cleared everything, it ran setup maze, which asked a certain set of patches to set themselves to magenta, and then it called the setup turtles function, which didn't do anything because there aren't any turtles. But now we've got an interface and we've got a program, we've got to start on a simulation. So I want to, let's see, what am I going to do here? I want to create some turtles and move them to random locations. You could create turtles here. So I could say create turtles 25. When you create a turtle, you can attach a block to it, which is initialization instructions. So for instance, so here I am asking it to create these turtles, and I'm saying make 25 of them, and then this block is going to say what we want to have each one do. Rand PX core, what that does is to generate a random patch X coordinate. So it'll be a valid coordinate for a patch in the X direction, and then random PY core does the exact same thing in the Y direction. Random. I knew they didn't look right because it'll color code them when they actually are recognized. Okay, there we go. That's what it should look like. Now it says this is okay. We're going to go back here. We're going to hit the setup button again. And we have 25 turtles that have been created on our maze. If I hit it setup, you see that they are generated. They're moving to random locations. Each turtle automatically has its own random heading and its own random color. But one of the things you might notice is if you look right here and down at the bottom, we have turtles that are sitting on the walls of the maze. And of course, we don't want them to do that. So one of the things I can do in the setup is to ask the turtles to move off of the patch they're on as long as that patch is magenta. So I'm going to go back to the code. Okay, so I'm asking the turtles because the setup function, that's part of what happens when I click the button. So that makes setup itself is an observer function because it's attached to one of the interface buttons, and setup turtles is called from it directly, which means it is an observer function. And actually, so is the setup maze function I did down here. It's a good idea when you're first starting out to actually label these things so you keep it straight in your head. What I'm asking it to do is to check the color of the patch that it is sitting on. So every patch has a color. It's called P color. That's to distinguish it from a turtle's color, which is just called color, because a turtle can read the color of the patch it is sitting on. So in this case, it's saying if the color of the patch you are sitting on is magenta, then move to a random location. Now, this will run into problems if if the starting positions of the turtles are not actually on a magenta patch. It won't actually randomize it, but you can, in fact, copy this and have a copy of this that's right before the while loop as well. So you could say, okay, randomize your location, then check if it's magenta, and as long as it's magenta, keep moving to random locations. All right, so now if I do this, it's not going to be a huge difference, but what should happen is that you look at the magenta maze walls, and at no point is there a turtle who is sitting on a maze wall. All right, that's really all I want in terms of setup. I want the turtles to be in random locations, facing in random ways, but not on the walls of the maze. When I program their movements, I will make sure that they don't move onto one of these magenta patches that represent maze walls. Now, I'm going to show you a couple of other things. I want to add a slider. So we're going to click and add a slider here. The global variable is going to be num turtles. Starting at, I think we want at least one turtle. Up to 100. The initial value is 50. That sounds fine. We'll just add that. I can select this and move it to where I want it to be. I just want it to be right here. What I want to do here is allow the user to specify how many turtles to create initially in the maze. So when I create a slider, that automatically creates the global variable that I can then use in my code. I don't have to declare it or anything. This is the declaration. So since I made this slider, num turtles is a global variable that I can use in my code. So here where I say create turtles, instead of saying 25, I can say num turtles, and it will know what I mean. Okay. Let's set this all the way up to 100, and we'll click setup, and we get 100 turtles. That's a lot. I can also use the slider to set it down to very few, and then I get very few turtles. So it's easy enough to initialize global variables that the user can control with the interface and that you can then use in your code. I'm going to show you a couple of other things. We're not really going to use them in this simulation, but just so you know that you can do this. So suppose that I want to be able to keep track of some features of the turtle. So as it moves around, maybe its health will decline, maybe it needs to find things in the maze to eat to increase its hunger, maybe it has a happiness based on how many other turtles are in view of it at any given time. So I want to set up something in the turtle that will track these extra attributes that I want the turtle to have. So I'm going to go to the code, and up at the top, I will add a command called turtle's own. So these are the turtle's own variables. These are essentially additional attributes, additional instance variables, if you like that terminology, that each turtle will have. So I can have health, hunger, and happiness. And then in here where I'm creating the turtles, I can actually set those. So there, I set health to 50, I set hunger to 0, I set happiness to 25. Those are somewhat meaningless numbers, but it's a way. I just wanted a chance to show you how we could actually add variables that belong to each turtle. Notice this is the form of an assignment statement. In Netlogo. So we don't use the equal sign with assignment statements. We only use it when we're doing Boolean statements. You say set and then the variable and then the value you want it to have. Set creates a new variable if it, set uses an existing variable and it updates its value. There is an additional keyword let that will create a new local variable and initialize it to some value. So let and set go together, but most of the time, if you're using things like turtles variables, it's going to be something like set. All right, we can also set up variables for the patches. I can do patches zone, and I could have turtle count, so maybe each patch could keep track of how many turtles had stepped on it, or something like that. I'm not actually going to use that in this simulation, but we could. The last thing I want to do is to talk about the movement of the turtle. So we've got a setup function. We're going to make a go function, to go. And it's going to end with end, as they all do. This is an observer function because it's going to be connected to a button in the main interface. So when I call go, it's the observer that's doing the going. And what I want the observer to do is to ask the turtles to move. So the most simple thing you could do in here is say ask turtles and say forward 1. That's really simple. This is going to violate the rules of our game, but our simulation. But just for now, I'm just going to leave it like this. This just says every time you hit the go button, each turtle should move forward by 1 space. Back in the interface, I can make another button, and I can call it go. So go will be the command, and go is the display name. Line this up a little. There we go. Good enough. When I click the go button, each turtle should move forward. And they are. Notice they are completely ignoring the walls because I didn't tell them to pay any attention to the walls. They're just moving forward by 1. It's kind of tedious to click this button over and over. So if I want to, if I edit the button, there's this forever checkbox that's a part of the definition of the button. If you click the forever button, then it's going to call go and just keep calling it over and over until you click the button again to make it stop. So now I'm going to hit setup. I'm going to make a few more turtles. If I just click go now, you can see there's a little icon in the lower corner. It's two arrows that form a circle. It's just going to keep calling go. The turtles are going to keep moving forward. This is really fast. There's a speed button. I can slow them down so that I can actually see them moving. And if I click the button again, they stop. Now, the problem with this is I want them to pay attention to the walls, and I don't want them to go onto step forward and move onto a wall if there's a wall ahead of it. So instead of having them just go forward by one, I need to have them decide what to do based on the patch ahead of them and what color it is. It turns out that patch ahead is defined in our dictionary to be the next patch. If the turtle moves forward by a certain distance, the next patch that it would have. So I can actually put an if else in here. So I want it to, if it sees a wall ahead of it, I want it to maybe turn away. And if it doesn't see a wall ahead of it, then I want it to move forward by one. So I'm going to use if else. And then I'm going to kind of build this up piece by piece because the syntax here is kind of complicated when you look at it as a whole. I want to ask something about the patch ahead. So patch ahead is a function that's built in. You tell it how far ahead. So patch ahead 1, that's a reference to the patch. That is one step ahead if the turtle moved in the direction that it's going. What I want to know is what's the color of the patch that's one ahead. So the way that I ask that is it's a reporter block is what this is called. There's a command called of, and before that you put a reporter block, and we can say report the color of patch ahead. P color of patch ahead 1. That expression means the color of the patch that is one ahead of the current turtle. And then we want to know, is it magenta? So I ask, is equals magenta. So I could just do this. I like to leave spaces around the square brackets just so they're easier to see. You don't have to. That's not part of the syntax. So what I'm saying here is if the color of the patch that's one ahead is magenta, then turn right by 90. Otherwise, move forward by 1. Let's see if, first of all, I'll click the check. Okay, everything looks okay syntax-wise. Let's set things up. And I'm actually going to make another button here. The command is going to be go. I'm going to call it step, though. I really like having a step button. It's exactly like the go button, except that it's not a forever one, so it only does one step at a time. All right, so I'm going to have them step. And let's watch. So these turtles right here, for instance, the green and that's actually a magenta one, they're moving straight for walls. So we want to see if they turn away when they get there. They do. They might have to turn a couple of times. This would actually really be easy if I only had a few turtles. Let's make there'll be like 4 turtles. Now that bright green one went away from the walls. Oh, the gray one's going away. The other gray one is going away. Yeah, so now the turtles are bouncing off the walls. If we kept track of the count of times that magenta has been stepped on, it would stay very small and would not be growing, which is good. So now I have turtles that can move through the walls. I'm going to make them go faster, slow things down a little so we can see what they're doing. Now you notice that some of them are stuck. This is where we talked in an earlier video about agents getting stuck sometimes. because of the way the rules are, these three turtles are just going back and forth and not ever exploring. The other turtle is going around in a bigger loop, but it's also stuck in kind of a track. If I don't want that to happen, I could change what happens when it sees a wall. So right now it's just turning right by 90. What I could do is to have it turn by a random amount. So to make it turn by a random amount, there are a number of different ways I could do this. What I'm going to do is to call the random function. And I can put parentheses around this, I think, without it causing problems, just to make it easier to read. I'm going to say random 180. This will give it a value between 0 and 180. If I wanted it to turn to the left or the right, I could do random 180 minus 90. And what that would do, I might actually need parentheses, though it doesn't just do random 90 here. I guess we will see. That would allow it, if you pass a negative number to the right hand turn, it turns to the left instead. So this would give me negative 90 to positive 90 as the distance for it to turn. Let's see if this, first of all, if it makes sense, and then we'll try running it. Well, the green one's not stuck. It does seem to take them a little longer. They're turning a fairly small amount. I did see one turn to the left, so I think my calculations are okay. I could instead, I just have them pick a new direction altogether. So I could just say random 360, and that would just turn to a random location, random heading, and move from there. And now if we go, we should see that they're following by the walls of the maze, but they're not stuck because the randomness is ensuring that they keep moving in different directions. All right, so in this process, we have started to see how to create the interface and how to connect it to our code. Hopefully you've also seen a few other things like the ways in which you can create variables in the code, a little bit of the syntax that's in the code, knowing that this check button is there as your friend to check your syntax before you actually try to run anything. The only other things I would note, I'm going to stop the simulation, is you can actually edit, view, and move the world itself. And if you look at it, you can see that you can change its settings. So if you want, this is right now got 32 by 32 for the patches, negative 16 to positive 16, so that's actually probably 33 by 33. And then it has, you could change that if you like. You can change whether the world wraps. You can change where the 0, 0 works if you want. So there are lots of different settings you can make, changes you can make to the settings for the world itself if you want to. All right, so now you have seen some of the basic tools for building simulations in Netlogo. You should go ahead and start making a simulation of your own. But remember, there's a lot to learn here, and it's a whole new programming language with its own perspectives, and so it'll take a little bit of time to master some of the more advanced features. And I may post additional videos if it seems like they might be useful. I will see you soon.